With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I hope you all are doing good. So today our question is like this. We have anhydrous AlCl3 is a covalent compound. Select the correct statement regarding AlCl3 based on the given information. Okay, our information is like this. Given the energy to ionize AlCl3 is 5215 kilojoule per mole. That is ionization enthalpy for AlCl3 is 5215 kilojoule per mole. We have delta hydration enthalpy for Al plus 3 ion is minus 4670 kilojoule per mole, and delta hydration energy, that is hydration enthalpy for Cl minus ion is minus 381 kilojoule per mole. Okay, now we have to select the correct option for this question. Our options are: it will remain covalent, it will remain ionic, it may or may not be ionic, any molecule being ionic or covalent is independent of ionization enthalpy. So basically this question is saying that when anhydrous AlCl3, which is a covalent compound, when it dissolved in aqueous solution, or we can say when this anhydrous AlCl3 is treated with water, or we can say when we take anhydrous solution of, or we can say aqueous solution of AlCl3, then what will happen? It will change into ionic form, it will remain covalent, it may or may not be ionic. So this is a question we have asked. Okay, so now let us solve this question. We have delta hydration for Al plus 3 ion as delta hydration for Al plus 3 ion. Delta hydration for Al plus 3 ion is minus 4670 kilojoule per mole. Kilojoule per mole. This is the delta hydration for Al plus 3 ions. Okay, and we have delta hydration for Cl minus ion is minus 381 kilojoule per mole. But as you can see, we have AlCl3, and in 1 mole of AlCl3 we have 3 moles of Cl chloride ion. Okay, we have 3 moles of chloride ion, so we have to take the hydration enthalpy for 3 Cl minus ions. Okay, because in AlCl3 we have 3 Cl minus ion. Okay, so delta hydration for 3 Cl minus ions will be 3 into minus 381. 3 into minus 381, because the delta hydration for 1 Cl minus ion is minus 381 kilojoule per mole, but we have 3 moles of Cl minus ion in the AlCl3, in 1 mole of AlCl3. Okay, so delta hydration for 3 Cl minus will be 3 into 381. Okay, minus 381. Then it will be equals to minus of 1143 kilojoule per mole. Minus of 1143 kilojoule per mole. So this is the hydration enthalpy for 3 Cl minus ion. Now we have to find the hydration enthalpy for 1 mole of AlCl3. Okay, so we have anhydrous AlCl3 which is in 1 mole. Okay, so delta hydration enthalpy for AlCl3 will be, okay, we have 1 mole of AlCl3, so delta hydration enthalpy for AlCl3 will be delta hydration of Al plus 3 ions, delta hydration of Al plus 3 ion plus delta hydration of 3 Cl minus ions, delta hydration enthalpy for 3 Cl minus ion. This will be the delta hydration enthalpy for AlCl3, or we can say change in hydration enthalpy for AlCl3. Okay, so it will be equals to delta hydration Al plus 3 is minus 4670 kilojoule per mole. That is equals to minus 4670 kilojoule per mole. Okay, plus what is delta hydration 3 for 3 Cl minus ion? It is minus 1143 kilojoule per mole. Minus 1143 kilojoule per mole. Okay, so net delta hydration for AlCl3 will be, so net change in hydration enthalpy for AlCl3 will be, if we add these we will get minus of 5813 kilojoule per mole. This will be the delta hydration enthalpy for AlCl3, for 1 mole of AlCl3. I hope you are understanding it. Okay, now we have hydration enthalpy. Okay, we have hydration enthalpy. and we have ionization enthalpy. Okay, I hope you guys are understanding it. We have two enthalpy for AlCl3, hydration enthalpy and ionization enthalpy. Okay, let me correct this spelling, guys. Wait a second. Ionization enthalpy. Okay, now what we have ionization enthalpy? We have ionization enthalpy as what we have 5215 kilojoule per mole. This is the ionization enthalpy. We have 5215 kilojoule per mole. Okay, so now let us back to our question. Okay, what is the ionization enthalpy? We have 5215 kilojoule per mole. Okay, and what is the hydration enthalpy for AlCl3? We have found that minus 5813 kilojoule per mole. So hydration enthalpy is 5813 kilojoule per mole. Okay, and this minus sign, this minus 5813 minus sign indicates that the energy is released. And this plus sign indicates that the energy is absorbed. So ionization enthalpy is the energy absorbed and hydration enthalpy is the energy released. But in this we have to take the magnitude of these enthalpy. The magnitude of this enthalpy. The magnitude of hydration enthalpy is 5813 kilojoule per mole and magnitude of ionization enthalpy is 5215 kilojoule per mole. As you can see, the magnitude of hydration enthalpy is greater than ionization enthalpy. The magnitude of hydration enthalpy is greater than ionization enthalpy. Okay, here minus sign indicates that the energy is released and this plus sign indicates that the energy is absorbed. So in this the 5813 kilojoule per mole energy is released. Okay, that is 5813 kilojoule per mole hydration energy released, and in this 5215 kilojoule per mole energy absorbed. Okay, so as you can see, the magnitude of hydration enthalpy is greater than ionization enthalpy. So this AlCl3 will become ionic. So what does this statement says? When anhydrous AlCl3 on treatment with water, it forms aqueous solution and this AlCl3 will become ionic. And the reaction will be like this. We have AlCl3 covalent, that is anhydrous AlCl3. When this on treatment with water, that is 6H2O, this reaction will, this AlCl3, this is a covalent compound, this AlCl3 will change into the ionic form, and the ionic form is like this: AlH2O whole 6 3 plus 3 Cl minus. This is the ionic form. So AlCl3 is a covalent compound, but when on treatment with water, or we can say when it treated with the aqueous solution, when this anhydrous AlCl3 will treated with the aqueous solution, then it will change into the ionic form, and the ionic form is like this: AlH2O whole 6 3 plus. This is the ionic form. But this is only possible when hydration enthalpy is greater than ionization enthalpy in magnitude. Okay, I hope you guys understand. So now let us back to our options. We have it will remain covalent. No, it will change into the ionic form. So this option is wrong. It will remain ionic. This is the correct option. That is, it will change into the ionic form when treatment with water. Okay, when anhydrous AlCl3, which is a covalent compound, on treatment with water, if delta hydration is greater than delta ionization enthalpy in magnitude, then it will change into the ionic form. So option second will be the correct option. Thank you guys.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.